Let's say that we have an observer here that looks at this object, and here we have a vertical plane in space that intersects the optical rays. So here is the observation point, and we join this point with every point of the observed object. These optical rays are intersected by this vertical plane that is called the perspective plane. If we connect those points, the perspective images, those points are the perspective images of the points of the object. If we connect them in the same way that the points are connected in space, we draw an image on this plane that is called the perspective image of this object as seen from this point of view. After this procedure, the perspective plane is rotated around this line that is called the baseline of the plane. So this plane is rotated around this baseline and is inclined on the horizontal plane here. Let's see this procedure in more details. So let's say that we have here the observer that looks at this square on the ground floor. And here we have the perspective plane with its baseline here. First of all, let's consider a horizontal plane that passes through the observation point O. This horizontal plane intersects the perspective plane at this line that is called the horizon line. The distance between the horizon line and the baseline, this distance, is equal to the height of the observation point. So to draw the image, the perspective image of this square on this plane, we need 2 points for each side of the square. For each side of the square, we need 2 points on this plane. So let's see the procedure. First of all, we extend the line. For example, we start from this one. We extend the line until it reaches the baseline of the perspective plane at point 1. Point 1, the perspective image of point 1 is point 1 itself. Because if we join point O with point 1, this optical ray intersects the perspective plane at point 1. So we have a point here through which it passes the perspective image of this side. We need one more point. Now we are going to join point O with the point of this side that is in infinite distance from the observer. That means that we're going to draw a parallel line to this one from point O. This parallel line intersects the perspective plane at the horizon, on the horizon at point Phi1. Point Phi1 is called vanishing point. If we join phi1 with 1, we have the perspective image of this line. We do the same procedure for this side of the square. We extend the side until it reaches the baseline of the perspective plane at point 2. Since those two lines are parallel, if we join point 2 with phi1, we have the perspective image of this side of the square. In the same way, if we extend this side of the square, we will find on the baseline point 3. Now we need to draw the parallel of this side from point O. And we find on the horizon line point phi2. If we join phi2 with 3, we have the perspective image of this side of the square. And we have here the perspective image of this point, and here the perspective image of that point. Here is this point, and here is the perspective image of that point. And finally, if we extend the final side of the square, we will find point 4 on the baseline, and if we join point 4 with F2, we will find here the perspective image of this point, and there the perspective image of that point. So we have the whole perspective image of the square as seen from this point of view. Now we have to rotate the perspective plane around the baseline and incline on the ground floor. So on the ground floor we have the baseline, we have the horizon line with the two vanishing points, we have the square, the perspective image, and the plan, the projection of the observation point on the ground floor, this point. What we do not have is the observation point. So let's see how we can draw this image without using the observation point. I mean that instead of using this point, we're going to use this one. So here we have the same observer that looks at the same square. We have the horizon line and the baseline of the perspective plane. First of all, we extend this side of the square and we find point 1 on the baseline. Instead of drawing the parallel line from point O, we're going to draw it from the projection of point O on the ground floor. And we will find on the baseline the projection of the vanishing point. From this point, we can draw the vertical line, a perpendicular line to the horizon line, and we can find here the vanishing point that we will join with point 1. So we have the perspective image of this side. In the same way, if we extend this side of the square, we will find point 2 on the horizon, on the baseline of the perspective plane. And if we draw the parallel line from the projection of the viewing point from here, we will find the projection of the vanishing point F2 there. And from this point, if we bring the perpendicular line to the horizon line, we will find here point F2. So if we join F2 with 2, we will have the perspective image of this line on the perspective plane. And here we will have the perspective of this point. So in the same procedure, using now we have already found the two vanishing points. In the same procedure as described previously, we can draw the perspective image of the square.